So, data warehousing, ayan. So, data warehousing definition. Data warehousing may be defined as a collection of corporate information and data derived from operational systems and external data sources. A data warehouse is designed with the purpose of inducing business decisions by allowing data consolidation, analysis, and reporting at different aggregate levels. Data is populated into the DW by extraction, transformation, and loading. Data warehousing incorporates data stores and conceptual, logical, and physical models to support business goals and end user information needs. Creating a data warehouse requires mapping data between sources and targets, then capturing the details of transformation in a metadata repository. The data warehouse provides a single comprehensive source of current and historical information. So, data mining versus data warehousing. Quite often, people confuse between data mining and data warehousing. While the two concepts are similar, they are not the same. The primary difference between data warehousing and data mining is that data warehousing is the process of compiling and organizing data into one common database, whereas data mining refers to the process of extracting meaningful data from that database. The two concepts are interrelated. Data mining begins only after data warehousing has taken place. Data warehousing techniques and tools include data warehousing appliances, platforms, architectures, data stores, and spread marts. Database architectures, structures, scalability, security, and services, and data warehousing as a service. Introduction to data warehousing. How it works. Warehousing combines information collected from multiple sources into one comprehensive database. To cite an example from the business world, I might say that data warehouse incorporates customer information from a company's point of sales system, cash registers, its website, its mailing lists, and its comment cards. Data warehousing may also consider confidential information about employee details, salary information, and many more. Companies use this information to analyze their customers. Data warehousing also related to data mining, which means looking for meaningful data patterns in the huge data volumes and devise newer strategies for higher sales and profits. So why it matters? Companies with a dedicated data warehousing team think way ahead of others in product development, marketing, pricing, strategy, production time, historical analysis, and forecasting and customer satisfaction. Though a slightly pricey option, it pays in the long run. However, data warehouse can also be very expensive to design and implement, and sometimes their construction makes them unwieldy. So, introduction to data warehousing types. Three
Iya ko na.
main types. Okay.
The three main types of data warehouses are enterprise data warehouse, operational data store, and
Data
data
mart.
mart.
Sige. Sige now.
Enterprise data warehouse is a centralized warehouse which provides decision support to organizing and representing data. It also provides the ability to classify data according to the subject and give access according to those divisions. Operational data store. Operational data store, also called ODS, is data store required when neither data warehouse nor OLTP systems support organizations reporting needs. In ODS, data warehouse is refreshed in real time. Hence, it records the employees. Data mart. Sandali lang.
Sige lang.
Data mart. A data mart is a subset of the data warehouse. It's specially designed.
For specific segments like sales or finance. In an independent data mart, data can collect directly from sources. Yeah. So, data warehousing architecture. In general, data warehouse architecture is based on a relational database management system server that functions as the central repository for informational data. In the data warehouse architecture, operational data and processing are separate from data warehouse processing. This central information repository is surrounded by several key components designed to make the entire environment functional, manageable, and accessible by both the operational systems that source data into the warehouse and by the end user query and analysis tools. So data warehousing architecture. Usually a data warehouse adopts a three-tier architecture. The three-tier architecture data warehouse is discussed. So first is bottom tier. The bottom tier of the architecture represents the data warehouse database server, also known as the relational database system. Backend tools and utilities are made use of to feed data into the bottom tier. These backend tools and utilities perform the extract, clean, load, and refresh functions. The middle tier. The middle tier of a data warehouse lies the OLAP server, which is an extended relational database management system. The rollup maps the operations on multidimensional data to standard relational OLAP model, which directly implements the multidimensional end operations. So top tier. This tier represents the front end layer client layer. This layer holds the query tools and reporting tools, the analysis tools, and the data mining tools. So this diagram depicts the architecture of the data warehouse. Ayan, yan ang architecture niyan. Kita niyo naman yata. Query, report,
Kita.
analysis, kumbaga. Hmm. So yung OLAP ay online yung OLAP pala ay yung OLAP server pala ay tinatawag na online analytical processing. So technology that organizes large business database ang OLAP. Yan ang OLAP server. Yan para malaman niyo kung ano ang OLAP. Ang hiwag ng OLAP na yan. So sunod naman. Data warehouse modeling. Data warehouse modeling is the process of designing the schemas of the detailed and summarized information of the data warehouse. The goal of data warehouse modeling is to develop a schema describing the reality or at least a part of the fact which the data warehouse is needed to support. Data warehouse modeling is an essential stage of building a data warehouse for two main reasons. Firstly, through the schema, data warehouse clients can visualize the relationship among the warehouse data to use them with greater ease. Secondly, a well-designed schema allows an effective data warehouse structure to emerge to help decrease the cost of implementing the warehouse and improve the efficiency of using it. So data modeling in data warehouse is different from data modeling in operational database systems. The primary function of data warehouses is to support the DSS processes. Thus, the objective of data warehouses modeling is to make the data warehouse efficiently support the complex queries on long-term information. So, yung DSS pala ay computerized program na nagsusupport sa ano parang sa judgment, sa actions ng ng organization or business mo. Yun ang DSS. Ang tawag dito? Decision Support System pala. So, data warehousing,
Yeah.
ayan. In contrast, data
Data,
modeling, ha? Ano yan?
sige. Kaya ka naman ano.
Sige, sige, ikaw.
Data warehouse modeling. In contrast, data modeling in operational database system targets efficiently supporting simple transactions in database such as retrieving, inserting, deleting, and changing data. Moreover, data warehouses are designed for the customer with general information and knowledge about the enterprise, whereas operational database systems are more oriented toward used by software specialists for creating distinct applications. Data warehouse model is illustrated in the given diagram.
So, ayan. OLTF, database, DBT, Rakel, etc. Optimized warehouse loader, data warehouse RDBS, query, tools analysis. Yan. Yan siya. Kung paano nangyayari.
Next,
Next na tayo. Ito. Sige lang, basahin
data
niyo na ako.
warehouse. The data within the specific warehouse itself has particular architecture with the emphasis on various levels of summarization as shown in the figure. Yan
So, ano
siya.
yan?
Highly summarized.
Metadata, highly summarized, lightly summarized, current level, saka order detail data. Structure of data inside the data warehouse. Yan baga. Nasa taas yung highly summarized, saka nasa baba yung lightly summarized. Yan. So, the current detail record is central in importance as it reflects the most current happenings, which are commonly the most stimulating. It is numerous as it is saved at the lowest method of the granularity. It's always saved on disk storage, which is fast to access but expensive and difficult to manage. So, older detailed data is stored in some forms of mass storage, and it's infrequently accessed and kept at a level detail consistent with current detailed data. Lightly summarized data is data extract from the low level of detail found at the current detailed level, and usually is stored on disk storage. When building the data warehouse, have to remember what unit of time is summarization done over, and also the components or what attributes the summarized data will contain. Highly summarized is compact and directly available and can be found outside the warehouse. So, metadata. Final elements of the data warehouse, and is really of various dimensions, in which it is not the same as file drawn from the operational data, but it is used as a directory to help the DSS investigator locate the items of the data warehouse, a guide to the mapping of record as the data is changed from the operational data to the data warehouse environment, a guide to the method used for summarization between the current accurate data and the likely summarized information and the highly summarized, etc. In this section, we define a data modeling life cycle. It is a straightforward process of transforming the business requirements to fulfill the goals for storing, maintaining, and accessing the data within IT systems. The result is a logical and physical data model for an enterprise data warehouse. The objective of the data modeling lifecycle is primarily the creation of a storage area for business info. That area comes from the logical and physical data. So, ito yung ano, ito yung data D, data life, data modeling life cycle, business requirements, logical data modeling, physical data modeling, fulfill business requirements for data storage. Yan. Siya ang life cycle nila. So, conceptual data model. Conceptual data model recognizes the highest level relationships between the different entities. Characteristics of the conceptual data model. It contains the essential entities and the relationship among them. No attribute is specified. No primary key is specified. We can see that the only data shown via the conceptual model is the entities that define the data and the relationships between those entities. No other data are shown through the conceptual data model. So yan. Example of a conceptual data model. Sales facts, data dimension, product dimension, geographical dimension. Siya na yan. So, logical. Logical data model defines the information in as much structure as possible without observing how they will be physically achieved in the database. The primary objective of logical data modeling is to document the business data structures, processes, rules, and relationships by a single view, the logical data model. So, ang features ng features nito, ano,
Specify primary keys for all entities. List the relationships between different entities. List all attributes for each entity. Normalization. And no data types are listed.
sige.
Yun
Ayan
ang
ang
feature.
logical data model. Data key full data. Amount sale,
Data
data key.
model.
Oh. So, physical data. Sige, ano.
Physical data model describes how the model will be presented in database. A physical data model demonstrates all table structures, common names, column names, data types, constraints, primary key, foreign key, and relationships between tables. The purpose of physical data modeling is the mapping of the logical data model to the physical structures of the RDBMS system hosting the data warehouse. This contains defining the physical RDBMS structures such as tables and data tabs to use when storing the information. It may also include the definition of new data structures for enhancing query performance.
So, characteristics of a physical data model. Specifications of all data tables and columns. Foreign keys are used to recognize relationships between tables. Step for physical data model design, which are as follows. Convert entities to tables, convert relationship to foreign keys, convert attributes to columns. So, yan ang characteristics niyan. Yung wag
Physical data model example.
Hmm. Yan mga physical data model. So, yan nga, data warehousing models. Yan yung mga types. Uh, Enterprise warehouse, data mart, saka virtual warehouse. An enterprise warehouse collects all of the records about subjects spanning the entire organization. It supports corporate-wide data integration, usually from one or more operational systems or external data providers, and it's cross-functional in scope. It generally contains detailed information as well as summarized information and can range in estimate from a few gigabytes to hundreds of gigabytes, terabytes, or beyond. An enterprise data warehouse may be accomplished on traditional mainframes, Unix, super servers, or parallel architecture platforms. It requires extensive business modeling and may take years to develop and build. So, Data Mart. Data Mart includes a subset of corporate-wide data that is of value to a specific collection of users. The scope is confined to particular selected subjects. For example, a marketing data mart may restrict its subjects to the customer, items, and sales. The data contained in the data marts tend to be summarized. Data marts is divided into two parts. Independent data mart is sourced from data captured from one or more operational systems or external data providers, or data generally locally within a different department or geographic area. Dependent data marts are sourced exactly from enterprise data warehouses. So, the virtual warehouses. Virtual warehouses is a set of perception over the operational database, where effective query processing, only some of the possible summary vision may be materialized. A virtual warehouse is simple to build but requires excess capacity on operational database servers. So, yan. Data warehouse implementation steps.
In
Hardware integration, modeling, physical modeling, ETL, extract, transform load, sources, populate the warehouse, use applications around the warehouse and applications. So, yan. Ganyan dyan.
data warehouse implementation. There are various implementation in data warehouses which are as follows. Requirements analysis and capacity planning. The first process in data warehousing involves defining enterprise needs, defining arch- defining architectures, carrying out capacity planning, and selecting the hardware and software tools. This step will contain be consulting senior management as well as the different stakeholders. Hardware integration. Once the hardware and software has been selected, they require to be put by integrating the servers, the storage methods, and the user software tools. Modeling. Modeling is a significant stage that involves designing the warehouse schema and views. This may contain using modeling tools. If the data warehouses are sophisticated, physical modeling. For the data warehouses to perform efficiently, physical modeling is needed. This contains designing and the physical data warehouse organization, data placement, data partitioning, deciding on the access techniques.
Sunod. Ay, ano ba yan? Data warehouse implementation. Sige, ikaw ka din. Sa'yo na. Kasunod pala niya eh.
Sige. Sources. The information for data warehouse is likely to come from several data sources. This step contains identifying and connecting the sources using the gateway, ODBC drives or another wrapper. ETL. The data from the source system will require to go through the ETL phase. The process of designing and implementing the ETL phase may contain defining a suitable ETL tool, vendors and purchasing, and implementing the tools. This may contain customize the tool to suit the need of the enterprises. Number 7, populate data warehouses. Once ETL tools have been agreed upon, testing the tools will be needed, perhaps using a staging area. Once everything is working adequately, the ETL tools may be used in populating the warehouses given the schema and view definition. Number 8, user applications. For the data warehouses to be helpful, there must be end user applications. This step contains designing and implementing applications required by the end users. 9. Roll out the warehouses and applications. Once the data warehouse has been populated and the end client applications tested, the warehouse system and the operations may be rolled out for the user's community to use.
Ito. Implementation guidelines. Build incrementally. Need champion. Bahanin na natin yan dito. Training. Business plan. So, build incrementally. Data warehouses must be built incrementally. Generally, it is recommended that a data marts may be created with one particular project in mind. And once it is implemented, several other sections of the enterprise may also want to implement similar systems. An enterprise data warehouse can be implemented in an iterative manner, allowing all data marts to extract information from the data warehouse. Need a champion. A data warehouse project must have a champion who is active to carry out considerable researches into expected price and benefit of the project. Data warehousing project requires inputs from many units in an enterprise and therefore need to be driven by someone who is needed for interacting with people in enterprise and can actively persuade colleagues. So senior management support. Data warehouse project must fully be supported by senior management. Given the resource-intensive feature of such project and time they can take to implement, a warehouse project signal for a sustained commitment from a senior management. Ensure quality. The only record that has been cleaned and is of a quality that is implicit by the organization should be loaded in the data warehouses. Corporate strategy. A data warehouse project must be suitable for corporate strategies and businesses goals. The purpose of the project must be defined before the beginning of the projects. So, business plan. The financial costs, hardware, software, peopleware, expected advantage and a project plan for a data warehouse project must be clearly outlined and understood by all stakeholders. Without such understanding, rumors about expenditure and benefits can become the only sources of data subversion to projects. Data training. Data warehouses projects must not overlook data warehouse training requirements. For a data warehouses project to be successful, the customer must be trained to use the warehouses and to understand its capabilities. Adaptability. A project should build in flexibility so that changes may be made to the data warehouses if and when required. Like any system, a data warehouse will require to change as the needs of an enterprise change. Joint management. The project must be handled by both IT and business professionals in the enterprise to ensure that the proper communication with the stakeholder and which the project is the target for assisting the enterprise's business. The business professional must be involved in a project along with technical professionals. So, ito pala yung reference. So, ito pala, tapos na. Okay na.
Tapos na yun.
Oo, ayos na.
5 naman.
Oo.
I-cut